This massive 3-ton block of steel and explosives dropping from the wing of a Russian fighter jet is an FAB-3000. It looks like a relic because structurally it is one. Its design dates back to the 1950s, drafted by the Soviet Union's State Special Design Bureau. At the time, Soviet aviation faced a significant mechanical limitation. Dropping unguided gravity bombs from high altitudes using mid-century optical sights meant that most payloads landed hundreds of yards away from their intended targets. Instead of trying to engineer more accurate targeting systems, Soviet military doctrine adopted a much simpler solution: increase the explosive yield so much that missing the target didn't matter. They built an entire family of these unguided weapons, scaling them up from hundreds of pounds to the absolute behemoth at the end of the line. That specific variant, the FAB-3000, weighs in at over 6,000 pounds. During the Cold War, raw, unguided mass was the most cost-effective way to guarantee the destruction of a factory or a bunker. This schematic shows the FAB-3000's mass distribution. The 3,500-pound solid steel casing punches through reinforced concrete and bunkers. Inside, the remaining 3,000 pounds is cast TNT. Detonation guarantees 100% mortality within 80 feet, causing catastrophic structural failure up to 2.5 football fields away. The original engineering is brutally straightforward. It is a giant, unguided, free-falling wrecking ball. Fast forward to the modern conflict in Ukraine, and that mid-century engineering becomes a severe liability. To use a gravity bomb, a pilot has to fly directly over their target to release it. Flying directly over a target means entering the range of Ukraine's dense network of surface-to-air missiles. Jets attempting direct overflights are routinely shot down. The standard alternative is to use modern cruise missiles. They can be fired from hundreds of miles away, keeping the aircraft safe. But cruise missiles are complex, difficult to manufacture, and cost upwards of $1 million apiece. Russia was burning through its stockpile of expensive missiles and losing aircraft to air defenses. They needed a method to deliver massive explosive payloads from a safe distance without exhausting their military budget. Their solution was the UMPK, the Unified Gliding and Correction Module. For about $20,000, this single kit is designed to turn a stockpiled dumb bomb into a smart standoff weapon. The application is decidedly low-tech. Ground crews at the airfield take these rusty Cold War iron bombs and attach the UMPK chassis to them using heavy metal hoop clamps. Because the original bomb has a blunt, unaerodynamic shape that creates drag, a hollow, pointed nose cone is bolted onto the front so it can slice through the air. Soldered flat against the chassis is a pair of spring-loaded metal wings. The exact moment the bomb detaches from the fighter jet, a small explosive charge snaps these wings open. To direct the wings, a tail computer uses a Cometa M satellite receiver to track coordinates, sending electrical signals to rear control flaps. Instead of falling straight down, the 3-ton weapon enters a shallow glide, traveling 30 to 40 miles from its release point. By combining a cheap computer, a metal wing, and an old bomb, Russian pilots can now launch devastating strikes while remaining dozens of miles behind their own lines, completely out of range of short and medium-range air defenses. On the ground, this modified weapon acts as airborne siege artillery. It is deployed primarily to break deadlocks by blasting massive holes through static, fortified defensive lines. These dug-in positions, often carved deep into the mud and reinforced against standard artillery, require immense shockwave energy to dismantle. When evaluating the system's performance, Russian state media claims the UMPK module can guide the bomb to within 33 feet of its target. But combat data tells a different story. Ukrainian electronic warfare units routinely jam the bomb's GPS receivers. When forced to rely solely on internal backup navigation, the weapon drifts, often landing up to 100 feet away from the intended mark. The hardware itself also suffers from reliability issues. The crude clamping mechanism and wing deployment fail often enough that dozens of these bombs have accidentally dropped onto Russian territory shortly after takeoff. However, precision is irrelevant when the payload is this large. Even if the navigation drifts and the bomb misses by 100 feet, the 3-ton blast radius easily swallows the error margin, crushing the target anyway. Defending against this specific threat is extraordinarily difficult. Once a 3-ton block of solid steel and explosive is gliding through the air, most interceptor missiles simply lack the kinetic force to destroy it in flight. The only viable counter-strategy is to shoot the Archer, not the Arrow. Ukraine must eliminate the Su-34 bombers before they reach their release coordinates. To push these Russian jets further away from the front lines, Ukraine has increasingly relied on long-range Western Patriot missile batteries and newly deployed F-16 fighter jets to establish a wider defensive perimeter. They are striking deeper into Russian territory, using AI-guided long-range drones to hunt the bombers on their own concrete runways before they even take off. The FAB-3000 highlights a brutal economic reality of modern combat. A military doesn't always need million-dollar precision engineering to gain a tactical advantage, especially when strapping $20,000 wings onto Cold War explosives can yield the exact same devastation.